All right, this video we're going to talk about number 3, excuse me, from the chapter 2 practice test. And so the basic idea, we've got this story here about college admissions, and essentially we're looking at, okay, what is the probability that we select some given group of students given the makeup of the students we have here. So as we look at this problem, the first one says, okay, what's the probability that all 5 chosen students are white? Well, I just need to know, first of all, okay, how many ways can I choose 5 white students? And then in general, it says, okay, we are going to randomly select 5 students. So how many ways can I select 5 students? As we know, when we think about the probability of some event, probability of some event A is just the number of ways A can happen divided by the number of ways anything can happen. So what are all the things that can happen? And I often like to think about that denominator first. Okay, what am I doing here and how many ways can that happen? So let's do that. I'm going to get rid of that because that's like just massive nonsense here. Okay, so the thing that's happening here is we have 22 students on our list, and we're randomly choosing 5 of them. So how many ways can that happen? Well, there's a couple ways I can think about it. I can absolutely think about it as 22 choose 5, because all 5 of these students are going to be treated equally. There is no difference between being the first name selected or the 5th name selected. They're all just being selected. But you can leave it there, 22 choose 5, that's fine. But I think it's helpful to think about, to really think it through and saying, okay, well, I am choosing 5 students. So how many ways can I choose that first student? Well, there's 22, so there's 22 options. And then for the second one, there's now only 21 options. And then 20 options. And then, 19 options. And then 18 options. But that implies that I'm doing this in a particular order, which is not true. And so I have to think, well, okay, for any group of 5 particular students, how many ways could those 5 students be rearranged? Well, 5 for the first, 4 options for the second student, 3 for the third, 2 for the fourth, and only 1 option left. If I divide that out, if I say, okay, well, this is the number of ways that I can actually rearrange any particular group of 5, then doing this division, okay, this is the number of ways I can put 5 people in order, but then divide out any reordering of the same 5 people, and I get my answer. And this is 26,334. That's the number of ways I can choose 5 students out of my pool of 22. Now I have to think about, okay, well, but I'm actually interested in knowing what's the probability that all 5 students are white. So I need to figure out, of the 8 students who identify as white, what's the probability, or how many ways can I choose 5 of them? And so that's similarly going to be 8 choose 5. And, actually I don't like how I wrote that line there. Let's do it separate. Just like in the denominator, it's going to be 8 times 7 times 6 times 5 times 4. 8 options for the first student, 7 for who's going to be the second, 6 for who will be the third, 5 for who will be the fourth, and 4 for who will be the 5th student chosen. But then, because again, all 5 of these students are being treated equally, they're all being moved to the accepted list, I have to divide out the number of ways that I can rearrange any particular selection of 5 people, which is 5 times 4 times 3 times 2 times 1. And yes, there is a button for 8 choose 5 on your calculator, but I think it's useful to go over what exactly is happening here. And if I simplify that expression, I will get 56. And then if I actually do that division, because the directions say list your answer as percentage rounded to the thousandths, if I do the division, I will get 0.002127 approximately, which as a percentage is 0.213 rounded to the thousandth percent. And again, the whole idea here is how many ways can I pick 5 out of the 22 people when order does not matter? How many ways can I pick 5 out of the 8 white students when order does not matter? Divide those things. Do the exact same thing for part B. Let's get rid of some of this. If you need to pause, write it down, go for it. But I'm going to get rid of all this. Actually, I'm going to keep that one because I'm still choosing 5 out of the 22 people. And what's changing is, well, what I want to happen, or, it's not that I want this to happen, but this is what I'm interested in. So my numerator, now instead of all 5 students being white, is 3 being black and 2 being Asian. So I have to think about, okay, well, how many students identified as black in the survey? 5, and I'm choosing 3 of them. So how many ways can I do that? Well, I've got 5 options for my first student, 4 for my second, 3 for my third, but the order in which I write those people down actually does not matter, so I divide out all the ways that I can actually select, or that I can reorder 3 of the same people from that group. And then I also need to select my 2 Asian people. Well, 3 students identify as Asian, and I'm only choosing 2 of them. So 3 options for the first student, 2 options for the second. And then how many ways can I rearrange any particular group of 2? Well, 2 different ways. Simplify that, and we get 30. Do the math here, and we're going to get about 0.001139, which as a percentage is 0.114%. Okay, that's number 3. I'm going to stop this video and do a separate video for the next question.